Hi, good day all. So I'm Anand here to discuss today on chapter 2, the binary logic gate, binary logics, right? We saw binary logic, chapter 2, we saw the number systems on binary logic. Now we are going to see logic gates. That is what we are going to see now. Hold on. I'm going to share now. Wait a minute, let me show the presentation. Okay. I think you'll be able to see now. Okay. So the class is NIOS Grade 12. Subject is Computer Science. Chapter 2 Binary Logic. And concept what you are going to see today is complements and logic gates. This is what we are going to see today. Right? So the primary use of logic gate is to perform logical operations on one or more binary inputs to produce a single binary output. So they are the building blocks of digital circuits and are used in almost all digital circuits and are used in almost all electronic circuits. Right? So what do we know in the past? What we know about this actually, right? Do you have any knowledge about complement of a binary number? Yes, because now yes. Previously no. Now because yes, because we just studied the number systems. Those who have not attended, those who are not able to, have not downloaded the video, and those who have not looked into it, is new for this. Otherwise you will know what is a binary number. It has the base 2 and it will use digits, only digits, 2 digits, 0 and 1. Okay, so do you know, have the knowledge about complement of a binary number? Complement is what? It represents the negative of a binary number. So complement, you have the ones complement and twos complement, we will discuss now. So there are two types of complements used here to represent the negative numbers: ones complement and twos complement. Twos complement is commonly used to represent the negative numbers in binary number. See, we have seen the binary numbers, but you have not seen the negative binary number is not there. So to represent the negative binary numbers, we use the concept called complements. So you should know about it, right? All right. Have you ever heard of logic gates before? Logic gates. So they are the fundamental building blocks of digital electronics. You should know about it. They are the fundamental building blocks of digital electronic. Each gate performs a basic logic function based on binary input values. So the input values are ones and zeros. There are too many gates are there, AND gate, OR gate. We will see one by one now. You should see the fundamentals of what is the fundamental function of logic gate, right? So they are the basic building blocks of digital electronics in today's world. You have to understand, because computers can understand only to one language, binary language, which is a machine language. 0 and 1 it can understand. All right. Next is, have you heard about truth table of logic gates? Do you know what is a truth table here? Truth table shows all possible combinations to a logic gate and corresponding output. You will see now. I'll tell you truth table. Out for each gate you have a truth table. If A is 0 and B is 1, what will be the output? If A is 1 and B is 0, what will be the output, and so on. We will see it. We are going to see now. So you should have some knowledge about, before learning. I just asked you, because if you have some knowledge, you can answer it. Right. So next is what? By the end of this lesson, you will learn what? You will learn the concept of ones complement and twos complement, how to produce the negative of a number. Right? In binary, there is no negative numbers. To represent the negative numbers, we use twos complement. Right? Learn the basics of logic gates and their functions. You will learn all the logic gates now with their functions and truth tables together. right? All right. So now learning time, right? So what are we going to study? We are going to start study one's complement, two's complement. What is one's complement? We are going to see now. We are going to work out on all those things. Two's complement. Two's complement is the normal usage. To find a negative number is using the two's complement. If you want to find the negative, two's complement of a negative number, say -5, you have to use the two's complement. I'll tell you now. So what will you next after that? What you will learn? Logic gates and truth tables. So AND gate, OR gate, NOT gate, NOR gate, NOND gate. All these gates you will use, and you will see the truth tables associated with it. Okay. Now see, we are going to learn all these things now. So now let us. I'll share now. I'll teach you one by one now. Yes, we will go for the one's complement and two's complement. We are going to learn now. All right. One's complement. Okay. One's complement is, suppose if you are writing a binary number. What is the one's complement of it? Invert all the bits. Invert all bits. What do you mean by that? If you have a 0, you change it to 1. If you have a 1, you change it to 0. That is what is called invert all bits. So here it will be 0, 1, 0, 0, 1, 0. So this is the one's complement of the above number. One's complement of the other number. What is two's complement? One's complement plus 1. What is two's complement? One's complement plus 1. Right? So suppose if I have the same binary number I take. Now what I do? I want to find the two's complement of this number. What I do? First I invert all the bits and then add 1 to it. So I invert all the bits, so you will get 0, 1, 0, 0, 1, 0. Now I am adding 1 to it, which will become 0, 1, 0, 0, 1, 1. This is the two's complement of the above number. Right? Say for example, I want to find the negative. See, I know what is 5. You can represent it as 4 bits. We have learned the number system already. So the 4 bits, 5 can be represented as 0, 1, 0, 1. 8 bits, it can be represented as 8 bits. How do I represent it as 8 bits? It's 0, 0, 0, 0, 0, 1, 0, 1. I am representing 5 as 8 bits. I can also represent it as 4 bits. Same number. So represent it. So now if I want to find the value of -5, I have to use the two's complement. Two's complement of 1, say first you find the two's complement of 101. So how do you find the two's complement of? First take 4 bits of the number. So 4 bits of the binary equivalent of 5 is 0, 1, 0, 1. You complement it. So it will become what? One's complement, you do it. So 1, 0, 1, 0. Now add 1 to it. So it will become what? 1, 0, 1, 1. This is actually -5 for this +5. Right? So -5, so you have to represent -5. You have to do the two's complement of 5. So you take the binary equivalent of 5. Okay, calculate the one's complement and then add 1 to it, which will become the two's complement. So two's complement will be the negative of the given number. So you convert it into decimal, you will get a 5. You add minus to it. That's all. It becomes -5. So to represent the negative numbers, we are using the complements here. Okay, so you should know how to find the complement of a negative number. using 8 bits. We can also find using 8 bits. Same number 1051, that is actually 5. You can write it as 0 0 0 0. Yes, we have 8 bits here. So when you complement it, that 4 bits I showed you. Now 8 bits is 1 1 1 1 1 0 1 0. Add 1 to it. You take the ones complement, then add 1 to it, which will become 1 1 1 1 1 0 1 1. This is the 2's complement of the above number. Same -5. I'm putting it in 8 bits. It is represented as 8 bits. So now you know how to find the complement of the numbers, right? Complement, one's complement, first you find it, then add 1 to it. You will get what? You will get 2's complement. That will be the negative representation of the given number. So now we will go for the logic gates. I told you this is very important in digital electronics. So we'll go to the logic gates. Right? We will see logic gates one by one. We will see. All right. Now, first gate that we have to know is AND gate. I'll go through that. Wait. So logic gates are what? As I told you, they are the basic building blocks of digital circuits. Okay, they are electronic circuits that perform logical operations on one or more binary inputs to produce a single binary output. So commonly used gates are what? AND, OR, NOT, NOND, NOR, XOR gate, XNOR gate, and so on. Too many are there, but we are going to see AND, OR, NOT, NOND, and NOR. These are all given in the textbook, right? So we have to see what is the circuit diagram of it, what is the truth table of it, what is the expression for the gates. We will see it one by one. All right, so we'll see the AND gate. Wait, let me show it now. Yes, AND gate. What is the function of AND gate? If any one input is, if both inputs are true, only then the results will be true. Otherwise, the result will be false. If both inputs are true, the result is true. If both buttons are pressed, the door will open. If any one button is pressed, the door will not open. That is the function of the AND gate, right? So if any one input is 0, the output is 0. So how will you draw the diagram? I'll tell you. See, AND gate, you will have two inputs, A and B, right? So I will write here. You see how I am writing. You have to give the inputs, and then this is done by a D symbol like this. And then this will be the output. This is nothing but A dot D, or simply AB. This is the circuit diagram of AND gate. So what will happen? So truth table, I'll write the truth table of it. Let me listen. Okay. So truth table, you see the truth table of it. I'll write it. Draw the truth table. What are the combinations? You should know the combinations. So A and B. So output is what? Output is nothing but A dot B, right? That is the output. So what is the output? So what are the combinations? It can be, both can be 0, or A can be 0 and B can be 1, or A can be 1 and B can be 0, or both inputs can be 1. So what is the output? I told you, A AND gate means what? If both the inputs are true, true means what? 1. False means 0. If both inputs are true, the result is true, else the result is false. Which means if both inputs are 1, the result is 1, else the result is 0. Very simple. So this is the truth table of the AND gate. So how do you write the expression? I write C is equal to, C is the output, so A dot B, or simply AB. So this is the AND gate. We learn all the gates one by one. Okay, so AND gate means what? If both inputs are true, the result is true, else the result is false. This is what is the truth table. You can take a note of it. You can take a screenshot of it. Have you all taken? Okay, all right. So we'll go to the next gate, that is OR gate. Let me do it. Wait. Okay. Let's learn OR gate. So OR gate, what is the function? I will tell you. Hold on. If any one input is true, the result is true, else the result is false. If any one input, if at least one input is true, the result is true, else the result is false. If any one button is pressed, the result is true. If both buttons are pressed, the door will open. If any one button is pressed also, the door will open. Otherwise, the door will not open. So that is the function of the OR gate. Right? So how do you write the circuit diagram? Circuit diagram I'll draw. So circuit diagram. So you should understand the circuit diagram. You should be able to draw the diagrams actually. So circuit diagram is what? Same A and B are the inputs. So it will go like this and you will draw like this. You see here? Yes, like this. And then this is called A plus B. This will be the output. How to draw the truth table? You have to write all the possible combinations, right? So you know A, B and output C, or you can write output here. So 0, 0, both the inputs can be 0. A can be 0, B can be 1, or A can be 1 and B can be 0, or both can be 1. So what is the combination? I told you if any one input is true, the result is true. So this is 1, this is 1 and this is 1. It is true. Else the result is false. Very simple. OR gate. This is called OR gate. Understood? All right. Take a note of it. Have you taken a note? Good. Very good. All right. Hold on. So let us go to the next gate. Wait a minute. 1 minute. Hold on. I'll just erase this. Yeah. So now let me go for the NOT gate. NOT is very simple. NOT is only one input is enough for that. So NOT is NOT gate. So what is it? Complement of input. Complement of given input. Say if the input is 1, the output is 0. If the input is 0, the output is 1. Invert the input. Say for example, circuit diagram. How do you draw the circuit diagram? I have A. So this one you have to draw a triangle, sleeping triangle, and draw a circle near it, and then loud. This will become A bar or A complement, like this. So this is actually truth table, only one input, no? So you will have only 2 rows. Truth table. So how do you draw the truth table? Truth table is A and A bar. A is 0, so A bar is 1. A is 1, A bar is 0. So how do you draw the expression? You draw C is equal to A bar. This is the output. Right? For AND gate, how do you write for AND gate? C is equal to A dot B. This is for AND gate. C is equal to A plus B. This is for OR gate. So C is equal to A bar. This one is what? For NOT gate. So if input is A, the output is A bar. Complement. You do the complement. Now next gate. 1 minute. Let me erase this. Okay. Next is NAND gate. It is a combination of AND plus NOT. What it will do? Whatever you have in the truth table, you see that whatever inputs you are giving, you will get an output you will get the complement of the output of the AND gate. Say for example, I have, see, NAND gate, I'll tell you how to draw the circuit diagram. You have A and B. See, now what happens? You have to draw a D and draw a bubble here near it. This one is what? This is nothing but A dot B, the whole bar, or A dot B, the whole bar, like this, whole bar. So now what is the truth table? It's just the inverse of the AND gate. What did I tell you? If both inputs are true, the result is true. Now what happens if both inputs are true? The result is false because it's a NAND gate. So A, B, and then output. So 0, 0 combinations, 0, 1, 1, 0, and 1, 1. So both inputs are true. The result is what? True in AND gate. Here it will be false. Even if one input is true, if both inputs are not true, if one input is true, the other is false, means it will be a true here. For AND gate, the first 3 will be 0, the last will be 1. Here the first 3 will be 1s, the last will be 0, because it's the inversion of the AND gate. Invert the AND gate. So C is equal to A dot B, the whole bar, will be the circuit, will be the expression for the NAND gate. Very simple. Next is what? NOR gate. NOR gate, what? It's already by the name you can see. It's nothing but OR plus NOT. Very simple. How do you draw the circuit diagram? Draw like this. Then draw the OR like this. And put a bubble here at the end. Now this is nothing but A plus B, the whole bar. Or A plus B whole bar, like this. So what is the truth table? It's the inversion of the OR gate. That's all. Truth table. So the combinations A, B, and C. C is the output, right? So I'm writing the ABC. Now 0, 0, 0, 1, 1, 0, 1, 1. Now, if any one input is true, the result is true, right? In the OR gate, here if any one input is true, the result is false. So 0, 0, 0. Here it is 1. You complement the OR gate, that's all. So these are the gates that are given in the textbook. So you have to know AND, OR, NOT, NOND, and NOR. 5 gates, 5 universal gates. These universal gates give rise to the other gates, right? This you have to know. All right. Okay. So coming back to the presentation now. Wait a minute. Hold on. All right. 1 minute. Please hold on. So what we have learned, we will see. Wait. Yes. Now you can see what we have learned. Binary logic forms the foundation of digital systems. I told you, right? Without zeros and ones, there is no circuit. Electronic circuits can't be formed. So that is the foundation, right? So what is the next one? What we have seen next? We have seen the decimal, binary, octal, hexadecimal. The number systems we have already seen in the last video. Now we have seen how they are interrelated, right? Then understanding the conversions helps in the design, digital design, right? So we have seen all these systems and we have seen the complement of the system. Complement of number system, that also is there. Here you have to add here what? You have to add complements. That is left here. What we learned? Complement of binary. Yes, that is left here, so I'm adding it. That's it. So we have learned all this, right? So next is what? Pause and think. Let me erase that. Okay, can you calculate the ones and twos complement of this? Let's do it here itself, right? Call ones and twos complement, pause and think. Can you do it? So what I do first, I invert all the bits. Then I add 1 to it. So it will become 0, 0, 1, 1, 0, 1, 1, 0. You add 1 plus 1 is 1, 0. So 0 and take a carry over there and you add it, you will get 1. So now what is the number? The number is 110, 110 to the base 2 is the answer. 2's complement of that number. Very simple. Right? So next is what? What is the primary difference between AND and OR gate? I have told you. If both inputs are true, the result is true in an AND gate. If any one input is true, the result is true in OR gate. That is the primary difference. So to complement an input, what gate? I already told you how to complement it. You have to use the NOT gate. NOT. Right? So complement an input. You have an input to complement it. You have to use the NOT gate. All right. So let's see one by one. What's the ones complement of this? Again, the same thing. I can give you some other number also. Say for example, let's take some other number and tell you, because we have already seen above, no? So I'll take 1 1 0 1 0 0. To find the ones complement, how do you find it? I invert all the bits. 1 0 1 1. This one is this is the ones complement. That's all. So what to do now? You have to do next question. Let's see what is the next question. The next question is, what is the twos complement? This one, twos complement is what? Let me tell you. So twos complement, you write it first, invert it. 1 1 0 1 0 0. Right? So that is the ones complement. Now add 1 to it. So you will get what? 0 1 1 0 1 0 1 to the base 2 is the twos complement. How easy is this? Right? So what is the next question? Draw the circuit diagram of A plus B dot A dot D whole bar. I will tell you, because this has not been told, but I'll tell you. See, what are you doing? You are having two expressions. A plus B is one expression and A dot D bar is second expression. You are ANDing A and D bar. You are ORing A and B, and finally you AND both 1 and 2. So what you do first? You have to do OR A plus B. So what you do? You have A and B. What you do? You OR it first. You OR it. So this is OR, right? You see now. Right? Now what you do? You, another one is what? I go here. Then you see how I am taking it. Don't write a straight line, which means that B is connected. Don't take it, because I want A to be taken separately. So I have to write like this. So this is A again. This is A again. You take another input D. You complement it. So this will become what? D bar. Now I have D bar. I have A. What should you do? Both. You are ANDing it. You are ANDing it. The second expression. So what I do? I am ANDing it. So A, this will become A dot D bar. What is the previous expression? On the top, you have A plus B. Now what I am doing, I take these two inputs I am taking there, and what I am doing, I am ANDing it. I am ANDing. So put a D here, and then you see here, this is actually the output. This output is what? Nothing but A plus B dot A dot D bar. So you will be asked to draw the circuit diagrams. Right? You can write the circuit diagram easily. Right? So you should know how to draw. For example, if you want to draw A bar plus B bar dot C bar plus D bar, understand? So what we do, we have to OR A and B complement. So I take A, I take B, and then I complement it. This will become A bar and this will become B bar. And I have C and D. I take both, I complement it. This will become C bar, and I complement this. This will become D bar. Now I am ORing the first two. I am ORing the first two, and then I am ORing the next two. Then what I am doing? I am unding both. That is what the final expression is. What I undid. So you will get that expression. That's all. Output is A bar plus B bar dot C bar plus D bar. Very simple to draw the circuit diagrams. I think you have understood it. I'll be sending the worksheets to you. Okay, so you can easily do all these questions. Okay, without any questions. So I'll be sending you PDF files on all these exercises on finding the ones and twos complement and how to draw the circuit diagrams about AND gate or gates. All the gates I'll be sending the worksheet. You have to complete it. Then you'll be very clear with it. Did you all understand about this one? Any questions? Any more questions? All right, that's great. So now we have completed the chapter 2, number systems and logic gates and their truth tables. We know what about the digital electronics is based on these two numbers 0 and 1, on and off, right? So we have learnt on the number systems, how to convert the number systems, the 4 number systems. We have learnt ones complement and twos complement, that is representation of negative numbers. Then we have learnt all the gates like AND, OR, NOT, NON and NOR gates, right? So second chapter is done. In the next video we'll be seeing chapter 3, right? That is a different chapter that we will learn it, right? Operating system and computer software. So we will be seeing something on that. Concept 1 and concept 2, it's divided into 2 concepts, and then we will learn one by one. All right, thank you, have a nice day, bye bye.